Okay, yeah, it's there. Okay, so the time complexity for one traversal of, okay, you guys will absorb this once you go through this page again after the class. What I'm trying to say is that there is one important paragraph written here. This paragraph in itself is very important. It says that the time complexity of an algorithm quantifies the amount of time taken by an algo to run as a function of length of input. That is why when we traverse this array just once, the time complexity to traverse this array is in order of n. Let's say if it was still m, then it is order of m. If the array was still infinity, then it would have been order of infinity. Note that the time to run is a function of the length of the input and not the actual execution time of the machine. The execution time of the machine, we don't know on which system, on which machine the algorithm is being run. So we can't predict or we can't actually quantify the actual execution time of the machine. But at least we can have some idea that how much time this algorithm will take based on our time complexity calculation. That is why there are few rules made that how to calculate time complexity of an algorithm. So any constant operation takes order of 1. Any arithmetic operation, division, multiplication, addition is order of 1 complexity, because it does not depend on the length of the input. The values will be simply stored in a register, they will be added and the output will be there. But when we are traversing or going through the array, it has to be done one by one. Like I has to be assigned value 0 and then 1, then 2, then n. And then only the value of the array can be extracted. Each element of the array can be extracted. So the complexity will be order of n. When the same array is being executed or being run in a nested way, or let's say a nested loop is there and whatever the calculation is there inside, for example, the algorithm which you showed me a while ago, the assignment which was given, it was nested loop. Regardless of the calculation which is done inside the nested loop, the order of the algorithm is always n square. So the total execution time is, they calculate it with execution time n square. We take the worst case scenario as there is a big O notation. Big O notation also you can go through. So this is the worst case scenario of any algorithm. So this is again a nested loop, right? This is a tricky one. In the first look, it seems like the complexity O n log n. You guys go through this page. We can discuss this once again next time. Like how the complexities differ for sorting, binary search, divide. Like there are multiple algorithms, those are already defined. And there are time complexities, those which we define for the same. Worst case time complexity is what we calculate, not the best case, because the input values can be anything. Space complexity is, let's say, any extra space that we use to calculate the output which we are supposed to. So the addition of two scalar number requires one extra memory location to hold the result. Thus, the space complexity of this algorithm is constant. Below is the implementation of the approach. Here, two arrays of length n and variable I are used in the algorithm. So the total space used is this. Let's say any extra space that is being used as a function of how many input variables are there, then that is the space complexity. If it is a constant, just one variable is being used, it's order of 1. If it's an array, then that is order of n. If it's half the array, then also it's order of n. Next time you guys come with, there is one important, there is one log in algorithm. You guys have learned binary search. Anyone? Has binary search been taught in any of the classes?
No, ma'am.
Okay, so yeah, we'll go through binary search this week, and your assignment is going to be how to calculate the time and space complexity of the binary search algorithm. So yeah, go through this page, and today's question will be about binary search. I guess I think I should. So usually my source of questions or source of solution will be from Geeks. I myself use Geeks for Geeks or Lead Code for any coding questions. So my source of the questions or solutions is going to be Geeks for Geeks and Lead Code. So you guys can always go through it, refer it. So let's go. Any of you guys, can you open the link that I shared just now? We'll go through what binary search is, and we'll solve one or two questions on binary search. Nikesh, can you share?
Okay, ma'am.
Okay, before that, did you guys get any hint of what I was discussing, like about space and time complexity? Like, did it make any sense what I was trying to explain?
Yes, ma'am.
Okay. Yeah, so can you tell in one or two lines what was it about?
It's how efficient is our programming code, ma'am.
Okay, yeah. So, okay, Lead Code is a website which will help you with your uh, which companies are asking which questions, how frequent the questions are. You can practice questions here, and like Geeks for Geeks is good for reading, but Lead Code is good for actually solving the coding questions there, then and there. So yeah. Binary search. We'll open. There are many questions on LeetCode on binary search. I think if you guys make all of you make an account here, there will be many binary search questions in LeetCode. We'll go through them after we go through this page. So let's say there is an input array of so many numbers, and we have to find number 110. Now, one important requirement for binary search is that the array has to be sorted. We cannot do binary search on unsorted array. So binary search is searching through an array by dividing it into half each time, depending on what element is being searched. So let's say we are searching for 110. Come down. I think there will be good animation telling how we'll search array. Okay, stop here. So it says the illustration search 23. There is a sorted array in the first line, 2, 5, 8, 12, 16, 23, 38, 56, 72, 91. We have to search for number 23. We'll divide the array into half. So the lower is index 0, higher is index 9, that is 2 and 91. When we divide into half or mid is 16. Now we check whether the middle element, that is 16, is it greater or is it lesser than the number we are searching for. So 16 is actually lesser than number 23 that we are searching for. That means we have to search for number 23 in the second half of the array. First half is not of any use to us. So we start our search from the index m, that is 4. Now there is third line. Again, we have now we make lower as 23, that is index 5th. Because we know that first half is not of any use to us, we'll assume that this is the only array we have from 23 onwards to 91. So we'll again do the exact same algorithm. We'll find the middle of the array from, so we find the middle as 7. Middle as 7 is 56. Again, we'll check whether 56 is less than or more than 23. (56) is more than 23. Now we have only, now we know that the array we have to search in should be before 56. So our lower becomes 5 and our higher becomes 6. Then if any of these elements is equal to the element that we are searching for, we'll return that element. So close this photo, we'll go through the algo once. Yeah, go up. In Leet for, sorry, Geeks for Geeks only. This is the iteration method. Yeah, there are two methods. There is one iterative method and there is recursive method. Let's stick to iterative method only for now. So it says that middle is low plus high. Low and high are the indexes of the array. So the function name is binary search array, and x is the number of elements, low and high. Repeat till low is equal to high. Mid will always be low plus high divided by 2. If any of the element actually matches, the x is the element which we are searching for. If it actually matches with the middle of the array, then we return middle of the array. But if x is greater than the middle of the array, then lower will be mid plus 1. And if x is less than the middle of the array, our higher will be mid minus 1. Did this algorithm make sense to you guys? Nikesh, did you understand this algorithm?
Yes, ma'am.
Any doubts? Okay, can you make account on everyone? Can you make account on LeetCode? Like while this class is going on, Nikesh, can you also make an account on LeetCode? We'll practice our questions there, like few questions. Currently, where are you running all your questions? All your algos? Okay. Okay, you have the okay. But LeetCode is good to practice other questions. Like you'll get set of new questions every day, and what is actually being asked in the companies right now, that is what LeetCode will help you with. You already have an account, is okay, cool. There will be, yeah, go. There will be a couple of binary search questions. Search for binary. Hmm. Come down. Yeah, this one open. You can do skip. Um, let's see which all languages do we have here. C++ is there. Come down. Python is also there. Yeah, I mean, you can choose the language which you're comfortable in. And we can use this. So there is, it's already defined that the search will contain all these, there is self, there is nums, there is list of integer, and there is target. Okay, we can start with the like how we calculate the mid. We'll start with it. Why are you commenting out mid? Don't comment out.
I came in.
Now, one better way to actually calculate mid in binary search algorithm is not really low plus high divided by 2, because it's usually mid is equal to low plus high minus low divided by 2. Add low plus high minus low divided by 2. Okay, list split Python. No, you don't need to split. Okay, one thing to understand here is you are not really splitting the list here. We just, I mean, splitting. We just have low and high as to traverse the array from low to high, but in reality, we are not really splitting the array. The array is intact, so we don't have to split. I think there will be a good YouTube video. I'm sure a good video on binary search. If I find it, let me find it, and it will be very easy to understand. Mm. There is this video that I found. Can you open this video? We'll go through it, and like it's going to make things clearer. But basically, there is one thing that we don't split the array. We don't actually split the array. Just lower and upper half we know using the indexes, but the array is always intact. Yeah, start the video. Let's find 48. Okay. 10 is the number of elements in the array. Okay, so there is one important thing is that we have to do it. The all this in a okay value is equal to list mid. Okay. Mm-hmm. Okay. If value is less than target, else if value is less than target. Okay. So in this array itself, we can see, right? Let's say value is 3, and if it is greater than target, that is 7. Where did your screen go?
Your voice is not audible.
Hello? 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 Audible?
Yes, ma'am. Your voice is clear.
Okay, okay. Okay, did he, I think he's, hello, Nikish? Nikish, did you join back? Okay, you're presenting again. We can see in this one of the inputs only, right? Let's say if our target here is 9, but if value that is mid came as 5, if 5 is target is 9, So at least in this case, value is less than target, that is 5, right? So we can write the case when value is less than target. If value is less than target, our low will be mid plus 1. Okay. That's all. That we'll have one more case. Okay. And this entire thing has to be done in a loop. I mean, this just has to be done every time a sub-array is found. So how do we, like, uh, before finding the mid, we have to run, every time we have to find a mid, right? So how do we run this in a loop? Either we can use for or we can use while. Here, a while is more advisable because for I is equal to 0, we don't want to find I 0 or 1 or till n. Like we can simply use while low is less than high or less than equal to high, while low is less than equal to high. Okay. Now we are returning at line number 8. What if we don't find the element in the list? Let's say in the example 1, there is this input array given and target is given as 9. What if target is given as 13? What if the element itself is not there in the list? What will we return from our function? We should return something, right? It's written, right? If target exists, then return its index on the left side itself where the question is defined. If the target exists, then return its index. Otherwise, return -1. There is no requirement of else case here. You can just return -1. You can remove this else case. It will anyway come here if. Mhm. Okay. Yes, I guess if syntactically this is correct, then logically this is correct. I mean, logically it looks correct to me. If syntactically it's correct, it should run. Can you try running the code once? There is a submit option. No, there is run option. Low reference before assignment. Okay, we can define low as something and high as something. Low can be 0 and high can be the index -1 of the function. Object of type has no length. Okay, maybe line 5 is search. List is of type int and okay. Len only should work. I don't know why it's not working. What is value here? Did we not assign? Target is int. Value is list of mid. No, oh, okay, okay. List is capital L. Will that matter? Oh my god. Parameters to generate must be types. Okay. Parameter to generate type must be type. Why I'm not sure what this error is. It looks like there is an error almost on every line. But they have defined a class. One thing to note is go up, class solution they have defined. Maybe that is why there is an error.
bro அந்த லிஸ்ட்டுக்கு பதிலா அந்த NAMS அதை யூஸ் பண்ணி பாருங்க.
What? The list is? Hmm, because um, yeah, this makes sense, right? Because low and high are not being changed, so this will be an infinite loop only. Yeah, the line number 10th and 11th, uncommented, those lines. Line number 10th and 11th, you comment out lines after that, then we'll know where the error is coming from. No, what did you change that this started happening after you assign a value of something? I think there is some problem with the assignment or okay. I think you guys can figure it out as part of your assignment how to get this value of list mid and try to do it in an iterative manner rather than recursive manner. So there are two ways to solve a problem. Either it's through iteration or recursion. For now, we'll solve the problems only using iteration. Let's not use recursive method. Let's only try iterative. But in iterative, how is the Python solution? We can look at it. There is one more question which I wanted to. No, this is actually an assignment that I'm going to give. And this assignment is for all of you. Okay, yeah, the first assignment for you guys is the lead code question of binary search only. Like all of you create a lead code account and try to solve this question using the language which you know. If it's Python, it's great. If it's Java, C++, C, anything is fine. I mean, algorithm is more important than the language itself. So this is try to solve this problem which we discussed today. Like all of you try to solve this, create an account and solve this. There is one more question. The binary search question we discussed and we know the algorithm, how we need to solve it. There is one more question. Find peak element, which is going to be the assignment. And try to solve it in your account only. After you create the account, you run the code and you submit it and see how many test cases pass in this account. So there is something called acceptance rate on the left side. Acceptance rate is how many times you're, like how many people submitted versus how many algorithms or how many times the code got accepted. So only 56% times it got accepted. Rest of the 44% times it got rejected because the test cases failed. So it was not the correct code. There is one more find peak element solution, which is going to be your assignment for today. And This is also a search algorithm, which using binary search, you'll be able to solve. So there is this binary search. In this, how do we calculate the time complexity of binary search? So any array or any list that gets divided by half or it gets reduced by half, the time complexity for the same algorithm is also reduced to half. So every time, let's say the first time list size is n, the second time list size is n by 2, the third time list size is n by 4, then it's n by 8. The input size keeps on decreasing, right? So anything which decreases by half with every iteration, the the complexity order is always order of n. That is big O notation. Big O notation is the worst case time complexity, which is log n. Big O notation, worst case time complexity. It is order of n log n for binary search because the input is becoming half with every iteration. How does this become log n? You can why is binary search algorithm? So is log and n better or is order of n better? So is log n algorithm complexity better or is order of n complexity better for any algorithm? Like is binary search better or is regular search better?
Binary search.
Will it take more time or less time? How much time will regular search take if we search through elements one by one? If we search elements one by one, it is going to be in order of n. If we search it using binary search, it's going to be log n. And log n is less than n, so our log n time complexity is going to be better. So the complexity, the order in which time complexities are better are as following. Time order of 1 that is constant is always better than order of n, and order of Can you open this page? There is this. Can you open this page? Yeah. So there is a chart given. Come down. That chart will help you understand how the time complexities. Yeah. So this is the chart. So the chart for order of n, as you can see, it's green line. The constant chart is the dark green line. Then there is light green, yellow. Order of n lies in yellow. Then there is n log n lies in orange. Then there is n square lies in almost red. Then there is 2 to the power n, which is worse than n square. And then there is order of factorial n, which is the worst of all time complexities. So any algorithm we write in future, we are going to remember that time complexity is the most important factor to think about. So the assignment for you guys is the question that I gave, find peak element. I'm going to write it formally. Assignment. First is complete the binary search question on LeetCode. Please feel free to use any language, C, C++, Java, Python. Second is this question. Where did it go? Second is this question, and try to run it and submit it. Once you get hold of how the I mean, you can also see suggestions in LeetCode how other people are coding, and you can get an idea of better algorithm in LeetCode. So, and yes, any algorithm you write, calculate the time complexity of all the algos. So, this is going to be the assignment for you guys. And in next class, we are going to learn about linked list and the uses of linked list. For now, we have binary search. Have you guys learned about sorting, merge sort, quick sort, bubble sort? Hello? Am I audible, guys?
Yes, ma'am.
So have you guys been taught about the sort algorithm, merge, quick, bubble, etc.?
Yes, ma'am.
In these classes or in your college itself?
College, ma'am.
College itself. So in college you would also know binary search also, right?
Yes, ma'am.
Oh, okay, okay. So it's just repetitive. But I mean, why I revamped the binary searches, because I wanted you guys to use LeetCode and become comfortable with it so that you can practice other questions on it related to binary search. Like you'll find many other questions related to binary search in LeetCode. Feel free to try all of those. Okay, so I think we are going to complete the class early today. Please complete the assignment by next Tuesday. We are done with the class, guys. Thank you. Thanks all for joining. Bye.
Thank you, ma'am.
Thank you.
Thank you,
Do you
ma'am.
guys have any doubts? Sorry. Do you guys have any doubts? Please feel free to ask. It feels like I'm the only one speaking. If you guys have any doubts, you can interrupt me and ask in between. I won't know if you have any doubts, right? Okay. So if you have any doubts, you can put it on Discord chat window or reach me on my email. This is my email ID. Any suggestions you want, you can reach out to me through email, Discord, anywhere. I'll be available. Okay. So thank you guys. Thanks for joining. Bye.
Thank you, ma'am.